By using the matrix, we need to prove that these set of vectors are linearly dependent, and we need to use the rank method over here. What is the rank method? If the rank of the matrix is less than the number of vectors, then the vectors are linearly dependent. And if the rank of the matrix is equal to the number of vectors, then the vectors are linearly independent. We need to show that the vectors are linearly dependent. For that, I need to get the rank of the matrix to be less than the number of vectors. How many number of vectors are there? There are 3 vectors. So the rank of the matrix should be strictly less than 3, either 1 or 2, right? So first we need to put all these vectors in the matrix format, and the matrix is writing the elements of the vector x. So this is 1, 2, minus 3 and 4. Then the elements of y, 3 minus 1, 2, 1. And then z, that is 1 minus 5, 8 minus 7. Let's reduce this matrix in a simpler format so that I can get the 0 row at last. Right? 0 row means all the elements should be 0, so that I can get the number of non-zero rows to be the rank of the matrix. Right? Okay. So what I need to do is, first I need to make this to be 0 and also this element to be 0. I need to get 0, 0 below 1. Right? So for that, what operation should I use? To get 0 in place of 3, let's multiply the row 1 with 3 and subtract this with the row 2. So changing the row 2 by multiplying the row 1 with 3 and subtracting the row 2 from this. Because I need to change the row 2, writing the row 1 and row 3 as it is. And now applying the operation, okay, multiplying the row 1 with 3, 3 into 1 and then minus the element of row 2. 3 into 1, that is 3, minus 3, that becomes 0. 3 into 2, that is 6, minus 1, that is plus 1. So 6 plus 1 is 7. 3 into minus 3 is minus 9. And minus 9 minus 2, that becomes minus 11. And 3 into 4, that is 12, minus 1, that is 11. And now I need to get 0 in place of this 1. For that, what we need to do is just subtract this row 3 from the row 1. That's it. So I need to change the row 3 by subtracting the row 3 from row 1. Because we need to change the row 3, so I am writing the first and second row as it is. Okay. 1 minus 1, that is 0. 2 minus 5, that is plus 5, that is 7. Minus 3 minus 8, that is minus 11. 4 minus 7, that is plus 7. So 4 plus 7 is again 11. So now this one becomes the leading element. What is a leading element? The element of the row below which all other elements are 0. Right? Okay. Now I need to make this to be the leading element. For that, I need to make this to be 0. So for that, just subtract these 2 rows. Right? So to get the row 3, I'm going to change the row 3 by subtracting the row 3 from the row 2. Writing first and second row as it is. That is 1, 2, minus 3, 4. And 0, 7, minus 11, 11. Now to write the elements of the row 3, we need to subtract row 2 and row 3. Okay. 0 minus 0, that is 0. 7 minus 7, that is 0. Minus 11 minus 11, that is plus 11. So that becomes 0. And 11 minus 11, again 0. So now I got a 0 row and 2 non-zero rows. So the number of non-zero rows after reducing the matrix becomes the rank of the matrix. How many number of non-zero rows are there? 2. So the rank of the matrix is 2. How many number of vectors given to us? 3. So the number of vectors are 3 because the rank of the matrix is less than the number of vectors. So the vectors are linearly dependent. Right? So we have shown the vectors are linearly dependent. Let's write this as the rank of the matrix is strictly less than the number of vectors. Therefore, the vectors are linearly dependent. If the rank becomes equal to the number of vectors, then the vectors are linearly independent. So because the rank of the matrix is strictly less than the number of vectors, the vectors are linearly dependent. This is what the rank method is. Okay, thank you. Stay blessed.